I'm Anil Kumar, and in this short video, we'll talk about what are important things to know before we start trigonometry and how to find basic trigonometric ratios, angles in a right triangle, and how to solve a right triangle. Into ratio, similar triangle, and Pythagorean theorem. Now, these three are very important topics for you to review before starting trigonometry. Then in basic trigonometry, we'll see primary trigonometric ratios. We'll determine value of each ratio. We'll try to find measure of angles in a right triangle. In a way, we'll solve a right triangle. So that is what we are going to do with few examples. And then at the end, we'll have a small test where we are going to answer these three questions. Solve each of the following right triangles. First right triangle has angle A equals to 30 degrees and the side A, which is opposite to angle A, is 5 centimeters. You need to solve. Solving a right triangle really means find all the sides and all the angles of the right triangle. Then we are given second triangle whose smaller side lengths are 7 centimeters and 24 meters. 7 meters and 24 meters. You need to solve this one. And the last question for you is, for what value of theta does sine theta equals to cos theta? Now, if you find these things simple, then you can actually skip this video, right? Now, let's begin by talking about ratios and similar triangles. So, let me give you one example here. Let's say we have two triangles. Let's say we have these two triangles. And let's say they are similar triangles, right? So similar triangles are triangles which have same angle, correct? So those triangles are similar. That means if I say that these two angles are equal and the second angle is also equal, two equal angles means similar triangles. Now, very important property of similar triangles is that their sides are also in fixed ratios, right? So they are proportionate. So that gives you an idea of ratios and similar triangles, correct? So let me write down their sides like this in the form of ratio. That is 12 is to, let's say this triangle, we have 12 is to 18 is to one unknown side. And since they are similar, I could write this as 14 is to this is unknown, and that one is, let us say, 28. So I have given you two questions which are actually exactly same questions. We are representing sides as ratios, and we are saying that these two triangles are similar, right? You need to solve these triangles. How will you solve them? Okay, so let's try to solve them first. Let's say this triangle, we are given two sides, 12, and this is 14 for us. We are given this side, let us say, as 18, and this we don't know. And for the other triangle, we are given this side as 28. Okay. Now, how do we solve this triangle? Now, to solve this triangle, what should we do? We know that they are similar, therefore ratios are same. We are given one ratio which is 14 over 12, right? So we know one ratio which is 14 over 12. So that is the ratio which is given to us, 14 over 12, which really means if I divide both by, or we could see like this. If I divide this by 6, I get 2, right? This also I can divide by 6. I get 3, and that can help me to get the ratio. So divide by 6 and times what? That gives you an idea. So if I divide both, I get 7 over 6, right? So basically what I'm saying is that the ratio is 7 over 6. That is to say, if I multiply 12 by 7 over 6, I get 14. Do you get an idea? Right? So that is what we mean by fixed ratios. Now, here is a question for you. You can actually pause the video, find these sides. Okay, so this is before trigonometry. You should know how to do it. Correct. So how do I get this side? So if I divide 18 by 6, I get 3, and 3 times 7 is 21. So this side should be 21. Do you get an idea, right? Now if I have to come back from here to there, I should divide this by 7, right? If I divide this by 7, I get 4, and 4 times 6 is 24. So this side should be 24. Do you get it? So that is what it is. You need to review this before getting into trigonometry. Since in trigonometry, we'll always find ratio of sides. Very important. Okay. Next thing which you need to know is Pythagorean theorem. So let me just make a triangle here, and then we'll try to see how to calculate the other sides, right? So if I take sides as let us say 25 is a good number. Let us say 20, right? You need to find that side. How will you find the other side? Well, let's use the calculator. We know from Pythagorean theorem that a square plus b square is c square, right? So this side will be square root of 25 square plus 20 square, correct? So we could just find it. So square root of 25 square plus 20 square is equal to our answer, which is 5 square root of 41. Correct? So that is a kind of summary of your right triangle. If you know two sides, you can always find the third side using the relation a square plus b square equals to c square, correct? Where c is hypotenuse, the longest side of a triangle. So we'll refer these two sides as legs. These are the legs of a triangle, and that is the hypotenuse, correct? So I hope these points are clear to you. Now let's begin with trigonometry. I really don't want to take a lot of time on those issues. In trigonometry, we talk about ratio of sides of a right triangle, basically. So let me sketch another right triangle, label it with few, we call this angle as theta, okay. Normally, we may refer an angle with the vertex. If I write A here, then we'll say angle A, right? Or we could use these Greek symbols, alpha, beta, gamma, theta, things like this. Okay. Now, this is a right triangle for us where angle B is 90 degrees. In this triangle, if we know two parameters, maybe combination of angle and a side, or any two sides, right? Two additional things apart from 90 degrees, we can always solve this triangle. Solving triangle really means finding all the angles and all the sides. Is that clear? Right? Now, with Pythagorean theorem, you cannot find what these angles are. Like, what is this angle? You don't know. And what is that angle? You don't know, correct? So that is a limitation. With trigonometry, we can also find the angles. Okay. Now, we'll refer sides with special names. We'll always call the longest side, which is opposite to the right angle, as hypotenuse. So in short, I'll write HYP for hypotenuse. The side which is opposite to the angle given, that becomes the opposite side. We'll write opposite side. And the side which is adjacent means with the angle and with 90 degrees. So that is called adjacent side. You can think like this. If we are talking about adjacent side with the given angle, in that case, the side will include the 90 degrees and the angle. So that is adjacent. Now, based on this, we have three trigonometric ratios. We call them by the name sine, cosine, and tangent. If we are using an angle, in that case, we write them in short form, sine as sin, lowercase s, right? and the angle, which in this case is theta, we'll say theta. For cosine, we'll write cos theta. And for tan is a short form of tangent, tan theta. Okay. So these are the three primary trigonometric ratios. When you say primary trigonometric ratios, we always mean sine, cosine and tangent, which could be written as sine theta, cos theta, tan theta in short. Okay. So that is one thing which you should know. Another thing which is important is, what is this ratio? They are basically ratios of sides in a right triangle. So what we understand here is that these three primary trigonometric ratios are ratios of sides in right triangle. Let me show like this, in right triangle, correct? So that is what they are. Now we'll get into this detail in the following sheet, and then we'll discuss how to use these terms to find the angle in a right triangle, correct? So using Pythagorean theorem, you could only find the sides, not the angle, correct? So let's move on now. So I have the same page, kind of, and again I'll sketch one right triangle here. So let's say this is the right triangle for us. As I said, we could always name the triangle with the angle or with the vertex. So let me call this as triangle ABC, and I'm going to name it now with the vertex. Correct? Three terms which we saw, which we say primary trigonometric ratios, they are called sine, cosine and tangent. In short, if we are using an angle, let's use angle A as the angle for a given ratio, then we could also write these three ratios as sine A, cos A or tan A. Now these are the ratios in a right triangle where sine A is equal to ratio of side which is opposite to the angle. So let me write down how we define these sides. This side is opposite to angle A, right? This is adjacent, and the longest is hypotenuse. So sine A is defined as a ratio of opposite side to hypotenuse. Cosine A is ratio of adjacent side to hypotenuse, and tan is a ratio of opposite to adjacent. So that is how we define the three ratios. And now we will see how to calculate these three ratios for a given triangle, and also how to find the angle, correct? We'll see all these things. So now in our triangle, let me give some sides to this triangle. So let us say that this side is 3. So let's say this side is 3. This side is 4. So we know the other side will be 3 square plus 4 square square root, which is 5, correct? Okay. So the other side will be 5, correct? Now if we know that in a triangle given to us, the sides are 3, 4 and 5, can you find what sine A is? In that case, we can say sine A is equal to opposite over hypotenuse. It is 3 over 5. Do you see that? How about cos A? Cos A is adjacent side over hypotenuse, which is 4 over 5, and tan A is equal to opposite over adjacent, which is 3 over 4. Do you see that? So that is so simple. Once we know all the sides of a triangle, we can always find the trigonometric ratios. Well, if you know two sides, even then you can do it. Since using Pythagorean theorem, you can find the third side. Okay. Now, we know that sine A is 3 over 5. How does that help to find the angle A, let us say? Well, now let's look into this. How do we find angle A? We can find angle A by using inverse relation, right? So let's get back to this. So we use inverse relation to find angle. From trig ratios. Let me show you how. So in this triangle, we know sine A is equal to 3 over 5. Then we can say that the angle A is equal to sine inverse of 3 over 5. Correct? Using calculator, we can find this angle. Let me show you how. So we have this function shift sine gives you sine inverse. So we can do shift sine, that is sine inverse, right? Sine inverse. Within brackets, we write 3 divided by 5, bracket close, equal to. So what you get here is the angle, which in this case is 36.8698. We wrote 4 decimal places. Now most of the time we are going to just round it to a whole number or 1 decimal place, right? So let me round this to a whole number. So we'll write this as 37 degrees. So we know that angle A is 37 degrees. We used sine trigonometric ratio to find that angle. Let me repeat this exercise with cos A and tan A. So if I say cos A equals to 4 over 5, then my angle A could be cos inverse of 4 over 5, correct? So let's do this time with cos. See what we get. Shift cos inverse 4 divided by 5 equals to 36.8698, exactly same. Do you see that? So this also gives us approximately 37 degrees. You can test it out for cos of the angle. Perfect. Always it will give you the same answer. Let us take another example. Okay, so let me draw another right triangle here just for practice. So let us say the sides are of a right triangle, let's say 9, 40 and 41. So the sides are 40, 41 and 9. This is a right triangle, and let's find the angle A. B is known to us, and C. First, let me write down any ratio. So if I say that, let me confirm if this is a right triangle. Is it okay? So what is 40 square plus 9 square square root? So it is square root of 40 square plus 9 square. It gives us 41. So it is indeed a right triangle. Correct? Okay. Now, let us find a trigonometric ratio and then the angle. It is up to you. You could use any of these 3 trigonometric ratios to find your answer. Correct? So let's use tan this time. So we have tan of angle A. We are doing example 2. Tan of angle A is opposite over adjacent, which is 9 over 40, correct? That means angle A should be equal to tan inverse of 9 over 40, correct? So let's figure this out. Shift tan inverse 9 divided by 40, bracket close, equal to. We get 12.6 degrees, 12.68 degrees, correct? Let's round this to 13 degrees. So if that is 13 degrees, then the other angle should be 90 minus 13. So 90 minus 13 is equal to 77. Perfect. So we know angle A is equals to 13 degrees and angle C is 77 degrees, correct? So in a way, we have solved our triangle. Now, how do we remember that these ratios are defined like this? So we have a small acronym. So sine is opposite over hypotenuse, SOH. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. SOHCAHTOA. This is how we remember it. Correct? So I hope the concepts are clear. We can now take up the test questions. Okay, here are the 3 test questions. The first one, we need to solve each of the following right triangles for given conditions. Well, that is separate. These are the 2 right triangles. The first one is, let me make one right triangle, then I'll fit in the values. First one here is, angle A is 30 degrees, so we are given angle A as 30 degrees. And side A is 5 centimeters. Always A and A, they correspond to one another. Sides are written in lowercase, angles in uppercase. So we get A, B, and C. So in this triangle, we'll assume right angle at P as drawn, correct? The second one is, smaller side lengths are 7 meter and 24 meters. Okay, so let me make another triangle and then we'll solve that one also. Let me draw it this side. Okay. So the sides given to us are 7 and 24, let's say 7 meters and 24 meters. We need to solve this triangle. Okay. You can actually pause the video, answer this particular question, and then look into my suggestions. Now here we are given one angle and one side. How do we find the other angle? Well, other angle is very simple. The sum of all the angles is 180 degrees. Therefore, angle C is equals to 90 degrees minus 30 degrees. So angle C is 60 degrees for us. So we have found that angle. That is simple. Now, how do we find these sides? We could use, if I am looking from 30 degrees angle, then this side is opposite side. As you can see, from 30 degrees, this side is the opposite side. Now the acronym is SOHCAHTOA. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. Since we know opposite side, we can find this side using tan and the other side using sine, since sine is opposite over hypotenuse. Is that clear? So let me use tan now. So I can say tan of angle is 30 degrees is equal to, opposite side is 5 and the adjacent is AB. Correct? So what is AB? We can cross multiply and find AB, correct? So we get AB equals to 5 divided by tan of 30 degrees. Does make sense? Let's figure it out. So we have 5 divided by tan of 30 degrees equal to 5 square root 3 is our answer. So this side is 5 square root 3. Do you see that? So we easily get our side. Now hypotenuse I can find using sine. So let me write down sine of 30 degrees is opposite side, which is 5, over hypotenuse, which is AC. So AC is what? AC should be equals to 5 divided by sine 30. 5 divided by sine of 30 degrees. Let's figure it out. So 5 divided by sine of 30 degrees is equal to 10. So we get our answer as 10. So we get this as 10. Now we did not use Pythagorean theorem to find that side. We could have used. But what you can do here is just check your answer. Add the square of these two. Do you get 100? That's the question, correct? So you can just check and verify. Okay? So you can check and verify. So let's do it. What is 5 square plus 5 square root 3 whole square equal to? Let's calculate. 5 square you know is 25, right? 25 plus this is 25 times square root 3 is 3, right? So 25 times 3 is 75, and we know that is equals to 100, and which is indeed 10 square, correct? So that shows that it works. Perfect. So that is how we can actually use trigonometry to solve triangles. We found the sides from the given angle, one combination of angle and side, correct? Let's do this one. In this example, we are only given two sides. We have to find all the angles. Now you have to see which two sides are given, and then we can find corresponding angle. So if I am looking from this angle, let me just name this as A, B, and C. In that case, 7 is opposite to A, and this is adjacent. So when we are talking about opposite and adjacent, I should use tan, right? So I say tan of A is 7 over 2. And that gives me that A is, that means angle is tan inverse of 7 over 2, correct? So let's figure this out. So we have shift tan, that gives me tan inverse. 7 divided by 2 bracket close equals to, we get angle A as equals to 74.05, right? So we'll just write 74 degrees. Let me write here 74 degrees. Perfect. So once you know one angle, which is 74, we know the other one, 90 minus 74. So angle C is equal to 90 degrees minus 74, correct? Which is 16 degrees. So we get this as 16 degrees. Perfect. Now if you have to find that side, you could use Pythagorean theorem, and you will get 7 square plus 2 square square root as your answer, right? Which is 49 plus 4 square root, and that is 53 square root. Is it okay? Now let me use trigonometry to find this side. Since that is hypotenuse, we could use one of these angles and then find that side. Our angle is rounded, correct? It is approximate, and therefore we'll get approximate answer, but we'll round it. Anyway, let's see. So that is the hypotenuse. So I could use sine of 74 degrees, which will be opposite side of 7 over AC. Now this means that side AC is equal to 7 over sine of 74 degrees, correct? So let's figure this out. So we have 7 divided by sine of 74 degrees, and that gives us 7.28. So this side is approximately 7.28. Let's find what is square root of 53. Square root of 53 is equal to, in decimals, also 7.28. Do you see that? So we get exactly the same answer. Perfect. So I hope it is absolutely clear to you by now that how trigonometry is very helpful in solving any right triangle. Correct? Okay, so we did first and second question. The third one is for you. For what value of theta is sine theta equals to cos theta? Now, sine theta and cos theta, if you see, sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. So for equal, these two sides should be equal. Is that okay? So what are we looking for? We are looking for isosceles right triangle, correct? So we are looking for a triangle which is kind of like this, where these two sides are equal. Is it okay? And that will happen only if the angle is 45 degrees. So this is true for theta equals to 45 degrees. Since opposite and adjacent sides will be equal, and then sine theta and cos theta will be equal in a right triangle, correct? So in a short way, we have understood what basic trigonometry is, and with this I think you can go ahead with your couple of chapters in trigonometry, especially all the chapters with right triangle. I hope that helps. Feel free to share your comments and views. If you like and subscribe, that'll be great. Thank you and all the best.